Or the scheme of homeostasis, maintenance, and function of the central nervous system. Open your paper and work together. This is variable. For example, blood pressure, glucose in the blood, each variable. Variable in the blood. Variable is some factor, substance of blood pressure, glucose, hydrogen ions, sodium chloride, everything, water content. It excites receptors. We discussed about it on the first lecture, but now I repeat to explain the function of central nervous system here. Receptors send signal to the central nervous system.
Yes, we studied that in the first lecture, right? We studied that in the first lecture, right?
Yes, but now we will repeat to understand the principal function of the central nervous system. A central nervous system, nerve center. Now you know nerve center. Nerve center here in this scheme means neuron circuit on the different level of the central nervous system, the brain, spinal cord, everything. Big nervous center, spread nervous center. And the blood composition influences nerve center directly through cerebrospinal fluid. Neuronal pathway, humoral pathway. So central nervous system receives signals from different receptors of the body. Signals about blood variables and external signals from external variables. External environment. So central nervous system estimates value of needs. What need is more important. For example, your blood glucose becomes lower. Blood glucose decreases. Central nervous system, especially hypothalamus, responds to it and excites regulatory systems. What regulatory systems do you know? Regulatory systems. What regulatory system do you know?
Voltage channels.
Channel is a mechanism. Regulatory system of the body. Common regulatory system. How central nervous system, how brain can influence on a factor. But you have blood glucose. What do you do?
Like hunger.
Hunger behavior.
Yeah.
Behavior.
Behaviors. Hunger behavior.
Factor. Behavior is determined, is controlled by need. Need forms motivation. Need. Yes. I don't remember how to write. Yes. Need. No? Biological vital need. Vital need. Vital need more important. Social needs is complicated to explain. Vital need. Vital need, physiological need. Like hunger, thirst, sleep, to sleep, behavior. What is the system? Controlling skeletal muscle. What is the name of the division in the central nervous system? What is the division of the central nervous system? that controls skeletal muscle. Somatic nervous system. How you can restore blood glucose until eating. For example, you can eat immediately. How your body maintains glucose concentration in the blood between eating.
I think it's autonomic.
You have done 4 hours between eating. How body maintains glucose concentration in the blood?
With using glucagon.
And
Glucagon and insulin.
glucagon, what is the effect of glucagon? What does glucagon do? Activate storage. The human signal to activate storage. Or autonomic sympathetic stress response. The same activates storage in the liver, release glucose or fat. So we have autonomic influences, autonomic nervous system, influences on organ, some organs, to restore blood variables with. You can explain instead of me. I will be explain. No, you want to talk. If you want to talk, I will give you possibility to talk. No, what? No. You talk. You're not talking now. Hormones. Hormones influence on organ. Hormones are released with control, under control, the central nervous system again. What is the function of the central nervous system? To combine signals from receptors, internal receptor, interoreceptor, exteroreceptors, about external environment, and analyze it with execution of regulatory influences. What is the function? To combine everything here, to have result, to maintain homeostasis. You have the list of central nervous system functions. What is the function here? To combine signals from receptors, signals about need, and what is the function? Produce regulatory influences. What is the main function? I explained yesterday. Combine. Integration. To combine everything means integration. Integration. What is the function to influence on organ? What is the function? How can we call it?
Feedback.
Feedback here. Well, how can we call influence on organ to have result? What is the function? Influence on some organ. What is the function? Simple word. Effector is organ. Effector. But what is the function? Receptors. Regulation. Regulation. Regulatory function. Here, regulation. Regulation means change of effector function, but not only change. Change for some. Change to have result, adaptive result. Regulation together with trophic function. Trophic function. What does it mean, trophic function? With stimulation of nerve innervating skeletal muscle, we use stimulation to have muscle contraction. But we have not only muscle contraction. In the body, it evokes sympathetic activation, and sympathetic influence on blood vessel change blood flow in the contracting muscle, and sympathetic neurotransmitter binds to receptor on the skeletal muscle. Sympathetic autonomic nervous system cannot contract skeletal muscle, but autonomic neurotransmitter can change metabolism of the muscle. It's trophic influence. Trophic influence means when neurotransmitter not only trigger response, immediate response, but second function neurotransmitter change metabolism. This response is change of function, change of metabolism, provides energy for function. Muscle contraction requires more glucose. And with time, growth of tissue. So what happens in athletes after regular training? Body mass rises. Why? Due to trophic function. With time, body mass, trained muscle rises in muscle. If you train your muscle regularly, twice per week, your muscle will be more. Due to trophic function. The same for each factor, as well as brain. If you train your brain has more possibility to work. It also trophic function. After brain injury, nerve fiber release special neurotransmitters, special trophic factors to recover nerve tissue. It's not only during adaptation, also after damage, after injury. It's trophic function. Regulation immediately, just moment. Trophic function is directed to adaptation, to future tension, new future signal. With regular activation of the system, which is integration, regulation, trophic. Then we have simultaneously behavioral response, autonomic response, and hormonal influence. What is the function? Activation of some organ and regulatory system together at the same time. What is the function? It is a function, activation together. For example, what happens during physical exercise? When you are running, your heart works more, heart rate increases, blood pressure increases, in the same time to provide physical exercise, adaptation. What is the function? To turn on several tissues, several organs, together. Coordination. Coordination. Here I show main function of the central nervous system: integration, regulation, trophic function, coordination. And behavior includes also mental processes, mind. Yes, mind is a higher activity of the brain, higher areas of brain, providing more correct, more adaptive behavior. Now, this is main scheme. Main scheme now about the details. I'm going to talk, to discuss about details and ask some students also about details. What is a functional unit of the central nervous system? What is a unit?
Neuron.
Neuron. So neuron must have the same function. Single neuron works like all central nervous system. This neuron must have integration due to synaptic inputs, a lot of synaptic inputs on the body and dendrite a single neuron. Body dendrite single neuron. Integration is provided by a process of summation. Integration here means summation. Summation. Summation, what potential are summed? Local, yes, local potential. Local potential, second name in scientific articles, graded. Summation of local or graded potential, EPSP and IPSP. EPSP and IPSP. EPSP, local depolarization, IPSP, hyperpolarization. EPSP is provided by sodium inflow, short-term sodium inflow. IPSP may have two mechanisms, chloride inflow or potassium outflow. Both or a single from this. Integration. On excitatory inputs and inhibitory inputs. What part of nephron evokes, generates the first action potential? In multiple neurons. What part of the multipolar neurons generates the first action potential? Where?
Helix.
Axon helix. It's called trigger zone. Trigger means to know. Trigger. Why here? Because this zone has the highest excitability. Here. Due to allotted sodium voltage gated channels with high sensitivity to voltage difference to depolarization. Probability to evoke action potential here is highest. How many action potential may be generated on axon helix membrane? How many? Single or several?
Single.
Several. Mostly several. Did you study computer sciences? How does computer work? Computer. Electronic systems. What is a code? What is a code?
0101.
Yes, binary. The same here. 1 is action potential, 0 absence of action potential. The same in the nervous system. Binary code, like computer. To transmit information, it's better to have several action potential. It's like binary code. For example, 2, then pause, then again. Several action potential. Why it's happened? Due to summation, continuous summation process. Continuously neuron receives signal on some synaptic input. Not all synaptic input works, of course, but neuron has a lot of synaptic input. Some from them works, and neuron work always to some incoming signals, IPSP, EPSP, and like here, one EPSP plus next EPSP now, on the one synaptic input, on the second synaptic input, hyperpolarization, perfect, sound, and when some potential or reach threshold остальные,
Here we have
it gets action potential. But for example, summation is prolonged. Some summation prolongs. It's continuous process, more summation, and all time while some postsynaptic potential prevails beyond threshold, neuron will generate action potential. The first, next, with more amplitude, more action potentials. Amplitude action potential doesn't change due to all or none law. Next, and less lower threshold, no action potential. One burst. Process of action potential generation called firing, from word fire, attach. It's a work of, that is work of neuron. Now, who can draw a scheme of temporal summation? Temporal summation scheme. Main scheme that I will ask on colloquium, we must draw now. Temporal summation. Зелая хура here. Mahmoud хура. Drop a scheme temporal summation. What is a temporal summation? What is it? But
Professor, I just know draw a
what?
picture.
What picture? Temporal summation draw. Can you? A single synaptic input with several action potential. It's action potentials, series, fire. And what happens here on the postsynaptic membrane? Research membrane potential. Incoming signal and prolongation from drawn. And then one more. Yes, okay. Now it's simple. My question is simple. Okay. It's process of your learning. Scheme of temporal summation. Membrane potential, minimal threshold, arrows mark incoming signal. Here 4, for example, 4 incoming action potential on synaptic input. It provokes for IPSP, EPSP is presentation, it reached threshold and get scheme of spatial summation. Заправный бор. Scheme of the same scheme of spatial summation. Spatial summation. Spatial summation. Spatial summation.
Okay.
Inspector is balanced. There's two different synaptic inputs. Each input acts active, and what happens here? What happens here? What is the result? Where? Here? No. Where? Again, what is the zone evoke action potential?
Here.
What is that mean? Where action potential and they go here. Only here. What happens here? Synapse. Так, Лейла. Лейла, которая... Аля, сиди, Лейла. There. Go. What happens on the postsynaptic membrane? The first second. What happens? Synapse, chemical synapse. And what happens here? What potentials? Local potentials. IPSP, IPSP1, here IPSP2. And what happens finally here? Yes, why? Draw a result. Those two EPSP are summed and increase amplitude. At first, action potential we will know. We don't know. Depends on amplitude. Big inside. No, here. Here, single. Big single. Spatial summation. Time is simultaneous. Together. One small are summed and produce big local potential. Big local potential. Local. It's only first part of the finish. We don't know. It depends on threshold. Anyway, big local potential. At first, local potential. To finish it, the same.
Finish point.
Draw it again.
Two EPSP are summed and give big local potential. If local potential reach threshold, we will have action potential. If doesn't reach, anyway, only local potential. Summed EPSP. If we have IPSP, it decreases. And well, more or less. Summation. Well, we combine neuron into circuits. You must know at least two main circuits: divergence or divergent and convergence. Моя Kazaniesz. A ranking. Najpierw.